Hi friends, I'm Chris from PhaseDoc. Welcome back for the second part in our 5-part series on industrial automation with an Arduino. The links to the rest of the series are in the description below. The last video we talked about how line benders work, and we mentioned some great reasons to automate the control of a line bender, including it's safer, you get more consistent and professional results, your efficiency goes up, and it can turn excruciating boredom into almost fun. In this video, let's talk about how to design a control to do just that. Let's review what we said. Honestly, every step after clamping the part down is prone to error, if not downright catastrophe. We're using a lot of heat, so things can catch fire. If you're really talented, you'll burn the house down. If you're just an amateur, you'll only scrap parts, but still. And watching your cell phone tick down 2 back-to-back cycles averaging 2.5 minutes each is not too bad for one part. Pretty painful for 20 or 100. Paying attention to a stopwatch means you can't do anything else at the same time, so it's inefficient and boring. We wanted to automate the process to address these issues. What are the main functions we would need in order to automate it? Well, we know we need a timer, and its main job is to throw a switch on and off at the right time. It would be nice if this timer would tell us when things are about to happen, so let's call that audio alerts. And finally, we need to communicate with it, so we'll need some type of user interface, right? I think we need an Arduino. Let's talk specifics. We're going to start with a microcontroller instead of a general purpose single board computer like a Raspberry Pi, because this is exactly the type of job microcontrollers are designed for. There are lots of good choices in the microcontroller world. The ESP family, Feathers, Particle is a great platform. There's the BeagleBoard family, Teensy. You could even use a microbit. But given all the resources available around this particular platform, it is hard to beat the Arduino family. For this project, I chose the Arduino Mega, not just because of its additional compute power, but because of all those extra I/O pins. As my friend Andre says, you can never have enough I/O, so this will be the heart of our build. Next, we need a switch, but not just any old switch. We want a relay, because we're controlling a large current with a small microcontroller that can't take that much current. But not just any old relay, we want a relay module, because of all the advantages that it brings. There are optical couplers to isolate your Arduino from those large currents, LEDs to show which relays are on at any given time, pins for easy control wiring, the ability to power the relay board separate from the Arduino. You can get 2, 4, or 8 relays mounted in a compact footprint, and you've got handy screw terminals to connect your load wiring to. All in a cost-effective package. It's a great way to go. For audio alerts, we could just use a simple 8-ohm speaker connected directly to the Arduino. What's left? The user interface. That's probably the biggest challenge with using a microcontroller, because unlike a single board computer, you usually can't just hook up a monitor, keyboard, and mouse to one of these and start interacting with it. What to do? I really like these 1602 LCD keypad shields that sit on top of the Arduino. They're called 1602s because the display has 2 rows of 16 characters each. There are also 2004s which have 4 rows of 20 characters each. So there. And for input, there's a 5-button keypad soldered in right below the screen. Let's take a closer look at that. In the center we have the up and down buttons. Off center we have the left and right buttons, or writhe if that's how you want to spell it. It's never done that to me personally, but your mileage may vary, so you might want to be a little careful with that one. Off to the far left we have the select or enter button, and then finally on the far right we have the reset button placed perfectly so that you can hit it anytime you don't want to. There are obviously space constraints that make this arrangement a bit snug, but in practice it works remarkably well, and the whole package is a very simple and cost-effective solution to the problem of communicating with your Arduino. Here's something you don't actually need, but you'll like it once you use it. This is a screw terminal shield that sits between the Arduino and whatever other shield you're actually using. In our case, the 1602. This shield lets you attach wires much more securely to your Arduino's I/O pins for a more robust deployment. Along the same lines, I like to use terminal blocks wherever it makes sense. These also let you attach and detach heavy wires with impunity, which is usually not the case with the other components you might be wiring up. You'll see both of these last two components in use when I show you how to wire up the actual controller coming up next.